Before trying the next lesson, why don't you try these warm-up questions? Write each of these expressions as a single power. So remember what a single power is: one base with one exponent. Pause the video and try it. Here you go. Multiplying powers with the same base, add the exponents. Dividing powers with the same base, subtract the exponents. Power of a power, multiply the exponents. Here we've got a combination. We're multiplying powers with the same base, so I'll add those first. Do the same here. Now I've got power of a power, so I multiply those exponents. Power of a power, so multiply those exponents. Now I'm dividing powers with the same base, so I subtract. 30 minus 24 ends up being 4 to the exponent 6. So that was just a quick review of your exponent laws before we get going. Now that you know the exponent laws, we're going to start adding algebra to this just to make it more fun. So this lesson is about simplifying algebraic expressions with exponents. So all of the algebraic expressions that we're going to look at in this lesson have exponents in them, and you're going to need to remember your exponent laws to be successful. I'm first going to talk about multiplying monomials. Remember what a monomial is. A monomial is a polynomial with one term. So when I'm multiplying monomials, I'm multiplying expressions with one term. Here's one term, 3m, multiplied by another one term, 4n. Here I have a monomial multiplied by a monomial multiplied by a monomial. So when I'm multiplying these monomials, it's just whatever term is in the brackets is multiplied by the term in front of the brackets. So when I have 3m times 4n, I just have to look at, well, what's 3 times 4? That's 12. And then I have the variable parts, m times n, well, that's just mn. So my answer here is 12mn. The next one is similar. I have negative 6a times 3b. So I look at my coefficients, negative 6 times 3, well, that's negative 18. And then a times b is just ab. So my answer here is negative 18ab. And my next one, 4a times negative 2a. Well, 4 times negative 2 is negative 8. A times a is a squared, a to the exponent 2. So my final answer here is negative 8a squared. So you have to remember those exponent laws. If you're multiplying a number by itself, then that's an exponent of 2. Let's do some more examples. Here I'm multiplying two monomials, a to the 5 times a to the 7. Remember our exponent laws. We're multiplying powers with the same base. So we're going to add the exponents. We end up with a to the exponent 12. For this example, we're multiplying 5x to the 4 times negative 3x to the 2. 5 times negative 3 is negative 15. We have x to the exponent 4 times x to the exponent 2. We're multiplying powers with the same base, so we have to add those exponents. It's x to the exponent 6. So my final answer here is negative 15 x to the exponent 6. And lastly, I have this monomial multiplied by this monomial. 4 times negative 2 is negative 8. A to the exponent 2 times a to the exponent 4. Add the exponents, it's a to the exponent 6. B to the exponent 3 times b to the exponent 5. Again, add the exponents, it's b to the exponent 8. So my answer is negative 8, a to the 6, b to the 8. Sometimes people will try to keep going and try to add these exponents together or something like that, but these are not powers with the same base, so you can't do that. You just have to leave it like that. That's as simplified as it gets. Here are some more. I've got 2x as my monomial raised to an exponent of 3. Now a lot of people just want to write 2x to the exponent 3 as their answer. But remember, 2x, the entire thing here, is the base of this power. So if I expanded this out, it would be 2x times 2x times 2x. Well, that's 2 to the exponent 3, x to the exponent 3. So 2 to the exponent 3 is 8. So this is actually 8x to the exponent 3. This next one is similar. Everything in the brackets has an exponent of 2. So we've got negative 3 to the exponent 2. That's negative 3 times negative 3. That's going to be positive 9. Then we have y to the exponent 3 to the exponent 2. So here we have a power of a power. Multiply those exponents. This is y to the exponent 6. So my answer here is 9y to the 6. For this next one, a lot of people freak out because they see fractions. Well, remember, we don't have to freak out with fractions. We just have to pause and think about what do we do when we're multiplying fractions. Well, let's think. It's a positive fraction multiplied by a negative fraction. Positive times negative. My answer is going to be negative. Then when we multiply fractions, the numerators get multiplied. So 2 times 3 is 6. And the denominators get multiplied. 3 times 5 is 15. So I have negative 6 over 15. Then I have to go look at my x's. X to the exponent 2 times x. Multiplying powers with the same base, I add the exponents. 2 plus 1, that's 3. So x to the 3. And then z times z to the exponent 3. Add the exponents again, so I have z to the exponent 4. Now, anytime you're working with fractions, you want to always make sure that your fraction is in lowest terms. This here is not in lowest terms, so we need to use our knowledge of common factors to find what this would be in lowest terms. I know that both of these values are divisible by 3, so this is actually negative 2/5 as lowest term. So my answer is negative 2/5 x to the 3 z to the 4. Now, all of this stuff that we've been doing can be transferred to when we're dividing monomials. So here I have 25x divided by 5. 25 divided by 5 is 5. So I have 5x here. I do the same thing here. I do the same thing here. I'm just dividing the coefficients, or the numerical part, and then I'm dividing the variable part, or the letters. And when I'm dividing the letters, the variable parts, I have to use my exponent rules. So here I'm dividing powers with the same base. So I'm going to subtract my exponents. So why don't you try to pause the video right now and try all of these on your own, and then you can check back here. So here they are. These are the answers. I'm going to go through them quickly. 25 divided by 5 is 5. We're left with an x. 12 divided by 2 is 6. X to the 6 divided by x to the 2. Dividing powers with the same base, so subtract your exponents. 6 minus 2 is 4. Here I have negative 36 divided by negative 9. Negative divided by negative is a positive. So 36 divided by 9 is 4. Y to the 4 divided by y to the 2. Subtract my exponents. I do the same thing here. Negative divided by positive is negative. 100 divided by 10 is 10. X to the 2 divided by x to the 2. Well, subtract the exponents. 2 minus 2 is 0. Subtract these exponents. 3 minus 1 is 2. If you have x to the 0, that just means that this whole thing is equal to 1. You don't have to write it. If you have an exponent 0, just don't write it. That's why I got rid of it. Here, positive divided by negative is negative. 14 over 21 in lowest terms is 2 over 3. A to the 2 divided by a is just a to the 1. And then b to the 3 stays the same. Now, just a note about this one. You could also write this one like this. They mean the exact same thing. Now, before we move on to the next examples, just remember, this is something we talked about in Spiral 1. This is the distributive property. So if you see something like this, it just means each term inside the brackets is multiplied by the number in front of the brackets. So we do 5 times 2x to get 10x, and 5 times negative 1 to get negative 5. So I end up with 10x minus 5 when I expand the brackets. So let's use the distributive property to solve these. We're going to expand and simplify if possible. So when I say expand, we're doing the distributive property to multiply out the brackets. Simplify if possible. So simplify just means combine your like terms if you have any. So for the first one, a times a is a squared. A times minus 3 is minus 3a. So we have a squared minus 3a. Those are not like terms, so that's as simple as it gets. For the next one, 4x times 3x. Well, 4 times 3 is 12. X times x is x squared. So we have 12x squared. Then we have 4x times negative 7. Positive times a negative, it's minus. 4 times 7 is 28. X stays the same as x. So we have 12x squared minus 28x. Those are not like terms, so we cannot combine them. This is as simple as it gets. We are done. For these next examples, the distributive property is the same. It's just we have more terms inside our brackets, but the idea is the same. Each of these 3 terms in the brackets is multiplied by the 2x in front. So we're going to do 3x squared times 2x. Then we'll do negative 6x times 2x. And then we'll do negative 1 times 2x. When we do all of that, we end up with 6x to the exponent 3 minus 12x to the exponent 2 minus 2x. None of these are like terms. They all have an x, but they all have a different exponent on the x. So we cannot combine these like terms. This is as simplified as we can get it. For this next one, here we have 2 sets of brackets. So this x gets multiplied by 3x. This minus 5 gets multiplied by 3x. Over here, the 4x gets multiplied by the 2x. And the plus 1 gets multiplied by the 2x. So we have to expand both sets of brackets first, and then we see that we have like terms. So now we can combine our like terms, and we end up with 11x squared minus 13x. Here's some more examples that are kind of a challenge perhaps for you. So you can pause the video and try these, use the distributive property, use your exponent laws, and remember if you have like terms after you expand, then you have to simplify them. So try it and then check back here to see how you do. So I expand the brackets, 3x times x, 3x times 2. Here, a lot of people get tricked here. You're subtracting everything in the brackets. You can think of it as a minus 1 in front. So everything inside the brackets is multiplied by minus 1. So essentially we're just changing the sign on all of these. It's negative x squared minus 2x minus 1. We have like terms, so we can combine those to get our final answer. Down here, expand, so multiply everything in the brackets by 4p to the exponent 3. Use your exponent rules. Do the same thing over here. Everything's multiplied by negative 3p squared. So watch your signs, watch your exponent rules, and then you have like terms that you can combine to get your final answer. So this all takes practice to get used to doing it, and when you try the practice questions, if you get stuck, you're not sure what to do, let me know and I'll do my best to help.